epidermis, yes. So this, and what else? The dermis. Okay. And that's where it ends. The subcutaneous or the hypodermis is not part of skin. Okay. It's there, yes, but it's not part of integumentary system. Okay? All right. Then the second part is what's in each, right? Let's go to the details. So once you understand this area is the epidermis, I'm sorry, this area. So you see all this funky thing here? Everything above this line is epidermis, okay? And then everything below is the dermis, okay? All right. So sweat pore, where is that? That's part of the epi as well as the dermis. Agree? I see. Well, actually, the sweat pore is up here. That's the duct. Okay, that's the sweat duct. Ah, and that's the sweat gland. Okay, so I'm just gonna pick on that number there. So I guess okay, everything in epidermis I would do in red. Okay. So let's kind of label. So epidermis would be in red. So what do we see here? We see sweat pore, agree? Coming out. Histology. Once upon a time, when we talk about histology, and in fact, it's in your lab list this week, I think, right? So what is this thing here called for histology? This would be the stratified. What else? Stratified, squamous, epithelium, yes? And it goes to here. And I can, the whole line, right? Everything above. Does that make sense? Okay, now, this thing here is only found on dry skin, correct? Look at dry skin. So what is this thing here called? Keratin. Right, so that's keratin. So when you see it, we call it keratinized. Does that make sense? So when the keratin is there, it gets the name keratinized stratified squamous epithelium. Okay. What is it? Anyone know what's keratin? It's a protein. It's a protein. And it's basically dead skin cells. Okay. Dead skin cells. Okay. What else? What else is found in the epidermis?
Hair shaft.
Hair shaft. Actually, hair shaft is above. So the part that you see, which we call hair, that's hair shaft. Okay, so this is above the epidermis. So what is this whole thing here? That's going to be the hair root. The hair root. So that would be the hair root. That's coming through the epidermis. Now, interestingly, you see how the epidermis kind of actually plunged down and followed the hair? So technically, do we leave the epidermis? Not really. I mean, yes, it goes into the dermis, but it's still surrounded by epithelial cell, right, technically? Anyway, so that's the hair root. Down here is the hair bulb. Get it? Hair bulb? Okay, doesn't get any easier than that. Okay.
Hair bowl?
Yeah, bulb, like a light bulb.
Bowl.
Bulb, yeah, B-U-L-B, like a light bulb. Okay. Alright, so anyway, okay. So let's now go into the dermis. Dermis has how many layers? You see? Two. Papillary layer and reticular layer. Okay. So what's the difference? Papillary is more superficial, yeah? And the word papillary, do you guys know what papilla is? Did I teach you guys this? What's a papilla? California papilla? It's like a little round hill, right? Papilla. Round hill. Do you see round hills on the dermis side? Yeah? So that's how it got its name. These little hills on the dermis side, that's called the papillary layer. Okay? The papilla is round hills. Okay? And then after that, you have reticular layer, which has a lot of goodies. Yeah? So almost everything else in this picture here. See, right here, dermal papilla. Dermal papilla, these round hills. Okay, so I'm just going to go in order. A rector pili muscle. Aha! It's a muscle. What do muscles do? Contract. And in this picture, yeah, in this picture, it connected to your hair, right? The hair mold right here. And if it contracts, it's shortened, right? If here's this muscle like this, if it shortens and the hair is lying like this, if it shortens, what happens to the hair?
It'll get pulled in.
Yeah, it gets pulled this way, and so now the hair stands up. Okay. So this connected to the hair is what get it to stand up. Aha. So what is the erect? What do you think? Does that give you a hint? Erect has to do with standing up, right? We are erect posture. We are standing straight up. So name kind of gives you a hint as to what it does. Yeah. Erector pili muscle. Okay. Smooth cardiac or skeletal muscle? Smooth. Yeah. Smooth muscle. To give you goosebumps, right? Lead to goosebumps. That's the layman term. Everyone knows what goosebumps are. Okay? So you think those are erector pili. Alright, then comes sebaceous, which means what? Oil. Okay. Sebaceous means oil. Sebum is oil. Okay. Sebum is that oily content. And in this picture, where exactly is it seen? They draw it around the, very loud, they draw it around the hair, around hair follicle. So is there a relationship between oil and hair? Yeah, it's called oily hair, right? And when do we get oily hair? When you don't wash it. Does that make sense? So over the hours, the sebaceous gland, which is here, wrapped around the hair, root, hair follicle, it's going to travel up, right? It has, when it mixes oil, it's going to travel up the hair to the surface, and that's what gives you oily hair. Make sense? Okay. So that's sebaceous oil gland. Alright. Sweat gland. Sweat gland. And the duct. So here's the sweat gland, here's the duct. Sebaceous gland, empty there. So what do you guys think? Sebaceous gland, sweat gland, are they endocrine or exocrine? Okay. 1 for endo, 2 for exo. Pick your vote. Endo is 1, exo is 2. Good. Is exo, because remember, exocrine glands have ducts. And in this case, you see here, there's a duct. This is the duct for the sebaceous gland, right? Because endocrine, remember we had spent a whole week last week, endocrine. The hormones go where? Go into the blood. That's not going to happen. Your sweat is not going to go into blood. Agree? Okay. So, exocrine gland, exocrine gland. And yeah, there's the duct, when you see. Let's do a quick review. Duct. What kind of epithelial cells line ducts? Yes. cuboidal cells. Ducts are usually cuboidal cells, line ducts. Which means what? Glands are what kind of tissue? An epithelium. Exocrine gland. Glands are epithelial tissues. Okay. All right. What else is in here? Gee, red and blue. Does that sound familiar?
Yeah.
Arteries and veins. And if you follow the little arteries and vein, it comes up and it gets smaller, right? So arteries and vein becomes what? Yeah, ultimately capillary, because you see how it goes from red to blue here, right? But before it becomes capillary, what do you call little arteries? Good. Arterial, and little veins are venual. Okay, so these would be arterial and venules, three. And then down here would be arteries and veins. Okay? All right. In addition, you see a lot of these adipose connective tissue underneath in the hypodermis. Make sense? Some of us have a thicker layer, some of us have a thinner layer. Okay, so that's your padding, if you will. And let's move on. These yellow things. What are these yellow things? Nerves. Nerves, okay, nerve endings. So the yellow are nerves, and the endings, like here, we call them nerve endings. Okay, not too hard, yeah? Okay, so a fancy name for nerve ending would be receptors. Okay, so nerve endings, receptors. Receptors. Okay, receptors. Okay? That's nerve endings, known as receptors. So they're sprinkled everywhere. Some of them are wrapped around the hair follicle. So what does that do? What do you think? Uh-huh.
Makes it hurt when you pull your hair.
Exactly, so that you know when someone just plucked your hair. Okay? Now look at this little nerve here coming to this thing. What is this thing here? This is the muscle. So why would you want a nerve coming to this muscle? To stimulate the contraction, right? Nerve will stimulate muscle contraction. Which, I know you haven't had a muscle chapter yet, so that's why I didn't do that. So nerve has to connect to the muscle to have it contract. Okay. Some of the receptors are superficial. Some of them are deep. Agree? So what do you think of superficial versus deep? How are they different? What kind of sensation might the superficial one pick up? Light touch. Whereas the deeper stuff will pick up pressure, right?
Pokes,
Deep touch,
punches,
yeah, a poke, correct.
punch.
A punch, yeah. Does that make sense? So based on where it's at, it kind of tells you what you're gonna pick up, what kind of sensation you're gonna pick up. Okay. Next week, we're gonna learn the specific name for these nerve endings. I'm just gonna call them nerve endings for now, and deal with it next week, okay? All right, but they do have different names. All right, so does this picture make sense? Any questions here? Okay, you guys wanna take a picture before I move on? So receptor, just know them as deep and superficial for now. Next week, we're gonna do a little more detail on these receptors. Okay? Okay, so the skin is called the integumentary system, and it has not just, it's also known as cutaneous membrane. Let's review. Membrane. We saw that word before, membrane. Anyone know what exactly is a membrane? Just review. It has two tissues. I'll give you a hint, two tissues. So, the last picture I showed you, what kind of two tissues did you see? Did you see epithelial tissue? Yes. So for sure, membrane means epithelial and what? Connective. That's what a membrane is. Now, what other membrane did we talk about in this semester? What is that? Visceral parietal stuff. Serous, yes. So we had serous membrane. Which had visceral parietal. Today we're talking about cutaneous membrane, right, for skin. That's the nickname for skin, is cutaneous membrane. You haven't had this yet, but you will in the next couple of weeks. Synovial. Synovial membrane. And anyone know where we have synovial membrane? Yeah, your joint. And then the fourth one is mucous membrane. And we saw this, didn't we? Where do we have mucous membrane? Airway, digestive tract. Then we had goblet cells with the mucus. So that was mucous membrane, airway, digestive tract with goblet cells. Anywhere you have goblet cells, that's going to be mucous membrane, okay? So those are the four types of membrane in the body. Today we're looking at only skin with a bunch of other stuff. Okay, so let's move on. Quick review. What's special about the skin? It's the largest organ, okay? Function you can read on your own. You know, most of it's pretty much self-explanatory. How many layers make up the skin? Two. What and what? Epidermis and dermis. So, deep to the dermis is hypodermis, not part of the skin, okay? So, hypodermis, you have fat, you have areolar tissue, okay, not part of the skin. Hypodermis. All right. So, where are we? We are in the epidermis. How many layers can exist in the epidermis? 5, right? So here they are. Text versus picture. So once upon a time, the whole thing is called keratinized, stratified squamous epithelium, yes? Because that was way back when, keratinized, stratified squamous epithelium. The whole thing, right? From here, up here. Today, you need to know the specific layers. This is what? Most superficial or deep? Superficial, okay, so superficial up here. And down here would be deep, right? Make sense? So, can I ask you to rank superficial to deep? Yeah, so here they are, listed for you. And then even beyond, right? Did we talk about down here as well? Hello? Yeah. So what comes after basali? It would be the dermis, right? But what specifically this area of the dermis called? papillary layer, right? And then comes what? The reticular layer. And then comes, okay, we're leaving the skin, hypodermis. And then way down here would be hypodermis. Okay, make sense? Okay. So they all start with the word stratum. Gee, what do you think stratum means? Layer. Yeah. Okay, remember stratifying many layers, right? So stratum is one layer. And so there's a technique called acrostic. You guys, if you look at my study strategy video, acrostic technique to memorize things. Anyone remember what's an acrostic versus an acronym? Yeah.
Using the first letter of each word,
Yes. To do what?
make a sentence
Yes, make a sentence.
or a phrase.
Okay. The first letter of each word to make a sentence.
CLG.
And it's, yeah, always better if you make the sentence yourself, no matter how stupid, silly it is, how personal it is, it's better that you make your own sentence. But some of you are like, what? Give me an example. Okay, so I'll give you an example of a sentence that a student wrote years ago, which I thought was kind of funny. Okay. So it doesn't matter what end you start. You can either start that end, start that end, but make sure you keep it in order, okay? And once again, you write your own sentence, you know. So this student wrote, bad school girls like Coke. So that was the sentence he wrote, and it works, right? Bad school girls like Coke. That makes sense? And so it works for him, you know? So like I said, you can make up your own sentence, and I encourage you to make up your own sentence because then you remember it more because you made it. And whereas if you memorize from someone else's sentence, you could, but it usually doesn't work as well. Does that make sense? Okay. So that's how you remember these layers. I recommend an acrostic. Okay. Okay. Or you just go by, just look at the word basali. What is basali? Basal. Basal means basement membrane, right? That's the end. So yes, all of this here, this very layers of cells on the bottom, or yeah, B for basal, B for bottom, right? There's layers of cells, just one layer. That's gonna be basali. And then right above that, you know, all of these squamous cells that you see, right? These are spinosum. That layer is spinosum. Spinosum. Then this top edge, just the top edge, is the, what layer? Granulosum. Now lucidum is special. Lucidum is only in thick skin. Only in thick skin. Yeah.
Thick skin's palms and feet, right?
Yes, correct. Palms and feet are thick skin. In other words, this layer, the keratin layer, is really thick. That's how we call it thick skin. Okay, so only in thick skin. And then the rest of the keratin, okay, so corneum, this is the keratin layer. Keratinized is the corneum layer. Okay? Understand? Now, some textbook, they give you a name called keratinocytes, and that's going to be here. Keratinocytes. Gee, what is site? Cells. What do these cells do? They make keratin. That's pretty easy. keratinocytes, spinosum, they make keratin. And then as they go up, they start to die, right? They start to die. Okay? So that's some of the details of these 5 layers. Any questions here? Okay. All right. So here's a picture of the two, thick versus thin. Is this pretty clear? Yes? Thick versus thin skin. Okay? See how thin this is? Any questions here? Okay, let's move on. Yeah, so thick skin is only the palms and the sole, and then thin skin is everywhere else in the body. Okay, now skin color. What dictates skin color? Melanin. Melanin, which is what color? Black. Good, that's one. Keep going. What else? Genetics, yeah, but then it gives rise to some kind of protein. So melanin is the dark hemoglobin, which is red, and keratin, which is orangey. Okay, so there you go. These are the 3 pigments we have to give us our skin tone. Okay, you've seen that before, yeah? You've seen that? Now, melanin, I think most of you know what melanins are. They're made by melanocytes. You guys like that word? Cells to make melanin. Hemoglobin. Where's hemoglobin? Red blood cells. Red color, yeah? And then lastly, keratin is an orangey. This stuff look like carrot, right? It's an orangey carrot. Yeah, that's from your diet, okay? Now let me look at some of the specific cells. Most of these are keratinocytes. Right? Most of these are keratinocytes. To make what? They make keratin, right? But, okay, so what layers is stratum what, guys? What do you guys think? Over here. Stratum what? Right, basale. So stratum basale, you're going to often find these melanocytes. What did this cell do? They make
Pigment.
what pigment?
Skin pigment.
Melanin. I should keep on like pigment, skin pigment, and when you say melanin, right? So the melanocyte is this weird-looking cell, and they make the little black dots called melanin, and that's what gives you your tan. Okay, the more melanin you have, the darker your skin will be. And then the melanin actually can go into the keratinocytes. So they get dispersed. So when you think the melanocyte will be activated to make melanin? The sun. Yeah, the sun is the stimulus. Yes.
How are the melanocytes and melanin connected with vitamin D?
Vitamin D is something that the sun will make when you are exposed to your skin will make when you're exposed to the sun. Okay. It actually doesn't, I don't think it relates to the melanocyte. Melanocyte is the skin pigment, not vitamin D. Okay.
But I think don't you need, sorry.
Someone calling.
I think, mom's though. No, I think you need, I don't know, when I was in microbiology, they said something about you need more vitamin D if you have more melanin or something.
I don't remember, but anyway, you can look that up, you can Google that.
Yeah.
Okay. But yeah, the melanocytes, remember, they make melanin and give you the skin color. Okay, I'm gonna tie this into endocrine. Anyone remember the relationship between skin and endocrine system? Last week. Was Was there something melano in there? Yeah, there was. Okay, so give me the rest of it. Melano what? MSH. What's MSH? Okay, so say the whole thing. M stands for melanocyte. S stands for stimulating. H for
Hormone.
so what did this hormone do?
Stimulates.
Stimulate the melanocyte. To do what? To produce the melanin. So when will MSH be secreted into the bloodstream? When you're in the sun. Who makes MSH? No, try again.
The anterior.
Anterior pituitary. Anterior pituitary makes MSH. And where does it go? It goes into the bloodstream and it goes down to the skin, right? Everywhere in the body where you have melanocyte, you have skin. And then it's going to activate the melanocyte. Does that make sense? All right. This is real tissue of a very dark skinned person. How do I know? Because this is all melanin right here. This dark thing, that's melanin. So this person is probably a dark skinned person for sure. Okay? All right, let me move on. We have skin markings, like a mole. Fancy word for a mole is amoebas. So we have freckles, hemangioma. That's your strawberry. This is a red. Bunch of capillary, that's all it is, capillary. But because it's capillary, it's going to be reddish because of red blood cells, and it on your skin, so it's a skin marking, you know. And then we have friction ridges. Friction ridges is what help us to grasp, to hold things and not slip. So in other words, friction ridges has to do with your fingerprints. Okay. Friction ridges. Okay, let's go to friction ridges. It's on your finger, palms, soles. Agree? So what is it? These folds between the epidermis and the dermis. And it helps to grasp, like I said, to hold things. And it's unique, as you know, right? Our fingerprints are unique to all of us. Okay, so, oh man, I don't have a picture of a friction ridge. Oh, that's no good. Okay, I'm gonna go Google. Let's Google a friction ridge. Okay, so here, you know, here's your, oh, sorry. So as you see, it's your fingerprint, right? But you look closely. If you look closely, what exactly is it? Is here. So that's your finger, but you look closely with a microscope. There's these little ridges. That's why they call them friction ridges, right? It's for you to grasp, for you to hold things. So these little ridges that we call fingerprint are these little bumps on your surface of your fingers and toes. And that's what leaves. Okay, so you really go into your fingerprint, these little ridges. It's for your skin, but that's what gives you your fingerprint. Okay. So what exactly is it? Look at this picture. So here's the epidermis, agree? Epidermis? Those are your friction ridges that gives you your fingerprint, okay? The epidermis. And then everything else we talked about is the dermis. So the top of your skin, the epidermis, is not smooth, correct? Especially on your fingers and toes. It's not perfectly flat. You have these funky folds, and that gives you your fingerprints, okay? Friction ridges. That make sense? Okay. Did you guys ever try putting tape on your fingers and you try to hold stuff? It's very difficult, right? But you got rid of your friction ridges. So if you ever commit a crime, put tape on your fingers. Don't leave anything behind. No, seriously. You know, take these little tape, just wrap your finger, and just like, you can't hold anything, but hey, you won't leave any fingerprints either. But don't tell them that you learned it in anatomy, you'll get in trouble. Okay, so, let's move on. So, in this picture, once again, does this look familiar? Yeah, I only took the top off, took so these are called epidermal ridges, okay, epidermal ridges. And then this is the dermal, get it? Epidermal, right? Epidermal, dermal, and their papilla, the little hills, versus the ridges, okay? And that's why stratified squamous epithelium always have this, you know, these funny up and down look. Okay. And remember, dermis has two layers. What layer? Papillary layer and reticular. Okay. Now comes something called, what is that? Lines of cleavage. Like what? Here we go. Throughout your whole body, they mapped it out where you have these lines, these parallel lines, front and back. Why are they important? You guys read this? Read this. Why are they important?
If you do it right, you can make healing quicker.
Do what right? Cut.
Make it cut in the right position on the
Yes.
spot.
So who might want to know this? Surgeon. Yes. So, you know, you gotta go in, gotta cut someone, you probably want it to heal as best possible, right? Minimal scarring. So it depends, do you make a horizontal cut or do you make a vertical cut? Well, it depends on where you are in the body because of lines of cleavage. You want it to heal with minimal scarring. Okay, so if you cut perpendicular to the lines, the cleavage lines, then you're gonna have ugly scarring. If you cut parallel to the line, then it heals a lot easier and there's less scarring, okay? So plastic surgeon would definitely want to know this, otherwise you'd be out of business, right? Okay. Remember, innovation, we're gonna talk about this more next week when I talk about sensory, okay? But today, just know that they're nerve endings, okay? And there are many of them. They're corpuscle, just sneak preview, we call them corpuscle, we call them just general nerve endings, lamellated. Okay.
What did you mention?
Okay. That's the knee. Okay. Now what else? What else on the skin is nails, yeah? And then we are not a beautician school, so I'm not going to like told you a whole lot of detail, but I do want you to know, so here's a cut through a finger. So you see the nail, right? The nail here. Here's the nail. So we have a nail bed underneath the nail, right? Just quick anatomy. Underneath the nail, you have a nail bed. By the way, nail. What the heck is nail? Keratin, exactly. That's keratin. But it's a hardened keratin, that's why it's tougher than your regular skin. Okay. So that's the nail bed. The nail root is where the nail grows, right? So, you know, nail grows all the time, you gotta clip all the time. And then the skin around your nail, it's cuticle, or eponychium, below is the skin called hypo. Okay. Hyponychium. Eponychium. Let's see. You have your skin, nail root. Yeah. So eponychium, the cuticle here, little tiny whitish area, lanula. Okay, so just basic nail, common nail anatomy. All right. What else is in this chapter is hair. Believe it or not, we have hair everywhere on the body. And hair is another form of keratin. This thing here is keratin. It's keratin. Different types of keratin, but still keratin. So we have it everywhere except for your thick skin, lips, feet, toes, and some of the external genitalia. Right. So 3 zones to a hair. Aha, remember this word? What's most superficial? Shaft. And then root, below the surface, the root. And at the very end is the bowl. Right? The hair bowl. So here's a quick picture. Does it look familiar? Okay. Pretty straightforward. Yeah, this chapter is pretty straightforward. Just pay attention. What's wrapped around the hair usually? Sebaceous gland, right? Oil gland. And then also what's wrapped around the hair root would be the reticular muscle. Make sense? And then you have blood vessel, little capillary down here, right? Blood vessel and nerves coming around. So that's pretty typical. Okay, what do you need to know? Let's cross-section a hair. Cross-section a hair. Innermost is the matrix, hair matrix, innermost. And then you have the cortex. Well, let me see. Maybe there's a picture. Find a better picture. Yeah. So innermost is the matrix. And you have outer cortex, inner medulla. Gee, does this sound familiar? Yeah. What else? Where else do we see cortex medulla? Kidney. What else? Adrenal gland. Lymph nodes, correct? So cortex medulla been seen over and over and over again, and then of course deep to the inner medulla will be the matrix, hair matrix. Okay. So yeah, that's good enough for hair. This is not nutritious. Okay. Throughout your life, you have how many kinds of hair? 3. This was in utero, or fetus. So you don't have this anymore, but it did when you were a fetus. Lanugo is what we all had when we were in mom's womb. Okay. Now we have terminal hair, that's this thing. Okay. Vellus is the really soft, downy hair that covers most of your body. Okay. So terminal hair is on the top of your head or your face. Beard. Vellus is everywhere else in the body. Really soft hair, right? Fine hair. Okay, so that's the 3 kind of hair. All right. Why? Why do we have hair? It protects your. Yeah. So protection. Retain heat. Believe it or not. Do you think it's warmer for a bald-headed guy or a guy with hair? Bald-headed, it's gonna be colder, right? That's what they need a cap. Okay, anyway. Also, facial expression, sensory receptor, ... Okay. Hair color, oh my gosh. Nowadays, you guys have all sorts of hair color. That's environmental or dye, right? The sun can bleach your hair, yes. Hormones can also play a role in your hair color. So hair color is mostly dependent on melanin. So melanin we saw was skin color, yes? But dark hair, the darker your hair, the more melanin you have. Okay. And then as we age, it becomes gray because the melanin stopped working, right? Or the melanocytes stopped working. Okay. We do have hair growth and replacement throughout our life. Sometimes it's impacted by drugs, right? Medication, like chemotherapy makes your hair fall out, okay? So the hair growth, it can be influenced by drugs, stress, radiations. And then over years, as we get older, what happens to our hair? It usually thin out, falls out, okay. Okay, wrapping up with the glands. Okay, get exocrine, right? What does that mean? Is there a duct or no duct? There's a duct. Alright, I need you to, okay, I'm gonna slow down now. We have sweat glands and sebaceous. What's sebaceous?
Oil.
Oil, okay? So, yeah, which is around the hair usually. Okay, so we have, we're gonna make two categories. We have sweat. So these are exocrine glands. Okay, so sweat glands, you have, it's also known as pseudoriferous. Pseudoriferous is AKA, is another name. And there are two main kinds, merocrine and apocrine. They're both sweat glands, okay? So sometimes in some textbooks they call it merocrine eccrine. I don't know why, but they do. So just, you see it, don't get confused, it's just sweat glands. Okay. So what's the difference between merocrine and apocrine? Apo, I remember apo as being the axilla and your groin. So in other words, these gives off a funky smell, right? Armpit and groin, when you sweat, it gives off the funky smell. So that's apocrine glands for you. Merocrine glands are sweat glands all over the body. Your arm, your hands, your legs, back of your legs, etc. will be merocrine sweat glands. Okay? You guys understand the difference? Location, correct? Location. Okay, and then what is sebaceous gland? Hello, what is sebaceous gland? Oil. Right, it produces sebum, which means oil. Okay? And it goes into the hair shaft, like we talked about, to the surface. So here's a picture of the different kinds of sweat glands. Okay? As well as, oh, by the way, what's the difference between merocrine and apocrine in this picture?
Oh, one's lower in the,
One's lower than the other? Okay, look again. Oh. Well, he goes into a duct that goes where? To the
hair follicle.
to the hair follicle. Aha. So we have apocrine sweat gland goes into the hair follicle. Okay. And the other sweat gland just goes straight up. Okay. Bypassing the hair follicle. Okay, so that's another difference between them. So location as well as hair follicle or not. So, apocrine goes into the hair follicle. So, true or false? We have apocrine sweat glands on your palm.
Oh.
We have apocrine sweat glands on your palm. It's false, because we have no hair follicle in the palms, right? So people who have sweaty palms, what's the problem? What kind of gland? Merocrine, right? Sweaty palms, Yes? That's the sweat, that's the American sweat gland. That's overly active. They do look different underneath the microscope. This is sebaceous gland. And then ducts are exaggerated, but it's cuboidal, okay, simple cuboidal. Okay, what other glands do we have?